Hello students, welcome to my lecture. In this lecture, we will see what is the concept of the differential equation. Basically, we will discuss about the general overview, what is the differential equation, what are their solutions, what are their kinds of the differential equation and so on. Myself, Dr. Harishkar, working in the School of Mathematics. You can simply follow my YouTube channel, Dr. Harishkar, for finding the all complete course on mathematics. So you all heard about this kind of the equations like dy upon dx is here. Sometimes you call as this partial are there. What is the meaning of that? What is the differential equation? Any of the equation which involves the derivative like of dy by dx, or you can say d square y upon dx square, or you can take about of here and so on. Any equation which involves the derivative or the differentials of one or more dependent variable. Remember, when you write dy over dx, the part of this that is on the numerator is called as dependent variable. This is my dependent variable, and this is with respect to x is called as independent variable. So any equation which involves the derivative like of dy upon dx, d power 4 and then so on, which may have one or more the dependent variables with respect to one or more independent variable is called as differential equations. For example, here, if you closely look about all these 6 examples, you have seen that some has of the dy by dx, some has the power 2, some has the partial derivative and so on. So based on this, we can classify this differential equation into the two category. One is called as the ordinary differential equation, abbreviated as ODE. Second is the partial differential equation. If you closely look about here, how many independent variables are there? So how many independent variables? Only one. In this case, in the second example, how many independent variables? There is only one, that is called as the small t. While in this case, how many independent variables? There are the two independent variables. One is the x, second is the t. In this case, there are the three independent variables. One is the y, second is the x, third is the z. So based on this nature, we can classify as a OD and PD. Any of the differential equation which involves the derivative with respect to the single independent variables is called as ordinary differential equation, and when it consists of the more than one is called as the partial differential equation. So clearly says that there is only one independent variable, so this is my OD. Again, this is the one independent variable, so this is also the OD. Again, this is only the one independent variable, that is the x, so we call as the OD. Again, this is my OD, while the last two are my PDE, partial differential equations are. So once you are categorized this differential equation into two category, one is the OD and PD. Now the major question arises is what is the order and what is the degree of the differential equation. So firstly, I will tell you what is the order. As I name suggests, the order, that is the highest order derivative involved in the differential equations. Look at that. In this case, what is the highest derivative? That is, what is the order is? That is the first order are there, because the highest derivative is dy by dx. What is the meaning of that? If I write of this form, that means this is of the nth order. How many times the derivative involved? In this case, what is the order is? The highest power is my fourth derivative, so it is the fourth order. What is the highest derivative of this is dy by dx. Again, it's the first order. It is second order. It is highest derivative is my cube, so it is of my third order, and it is my second order. So clearly says that the equation number 2 has of fourth order, while this is of my first order, and this fifth one is of my third order. Now once you are defining the order of the differential equation, now we can define the degree of them. If you closely look about that, what is the degree is? The highest derivative involved, but it should be free from the radical and the fraction. For example, if you look about this third case, it is in the form of fraction. Fine. So you have to firstly free from them, and then you can count the degree. You can see that these are my radicals. So you have to free from the radicals. For example, what is the highest derivative occurring in the degree of the highest derivative? What is the meaning of the highest derivative is? That is the order. So what is the degree of this highest is 1. This is my 1. What is the highest degree of is again a 1. But in this case you may observe that highest degree is my 1, but it is from the fraction. So you firstly free from the fraction, that is you have to multiply both side by root dy by dx. Now you have to see, this is my equation. Now it's clearly from the radicals, it is free from the fraction. So now what is the degree of this? That is my 2. Highest derivative is my 2. So make sure that it should be free from the radical and the fraction. So clearly say that how you can remove them. You can firstly scaling on the both side. Once you put the scaling on both sides, then it will be power 2 and it is free from here. Now it is free from the radicals, it is free from the fraction. Highest order is my 2, so the degree is again the 2. So the fourth option is my of second order. In this case highest order is my 3, so power is 3, so that's why it's of the third degree. For example here, so again we can consider the same examples. Now we can discuss the linear and the nonlinear differential equation. What is the meaning of that? Any of the differential equation, any of this differential equation is said to be the linear when it satisfies the two properties. Number one is every dependent variable, like in this case, for example, in this case, what is the dependent variable is y, and every derivative, what is the derivative is either dy by dx, either d square y upon dx square, or any of them occurs in the first degree only. What is the meaning of that? It means the first, remember it's a degree, so it means it can be of power, highest power is my 1 is there. And the second is no product of the dependent and of its derivative. What is the meaning of that? That is y dash is not be involved, y double dash is not be involved, y square is not be involved, y dash y double dash is not be involved. When any of the differential equations satisfy these two properties, then we call as the linear, otherwise we call as the non-linear. Look at this example, clearly says that this is my dependent variable, the highest degree is my 1, but also you can see there is no product form, so this one is my linear. Similarly for here you can see that this violates my second property, no product of the derivative and or their dependent variable, so this is my non-linear. Look at that, if you rationalize them, what will happen? It will give you a dy by dx of whole square, that is a product of dependent and their derivatives. So again it is a non-linear. Clearly say that it is a non-linear because of this, again because of this 3 it's a non-linear. What is that? This is a linear arc. Now make sure that there is a one remark for you here. Whenever the degree of any differential equation is greater than 1, then it is always be a non-linear. But make sure the converse need not be true. That is, whenever the degree may be 1, but it can be a non-linear, like of this. You can see that. What is the order is 1, degree is 1, but it is a non-linear because of this failed to satisfy this second property. So look at that, you have to find the order, you have to find the degree, and also classify whether they are linear or non-linear. So we will discuss all these 8 examples in this case. Firstly, you have to find the order. So order is very simple, there is no condition that what is the highest derivative is 1. What is the degree? It should be free from the radical, so you have to multiply this by y dash, so it will be root x y dash square plus k. Now clearly says that highest degree derivative is my y dash, the power is my 2, so it is my 2. Now since the degree is 2, so it is a non-linear, or otherwise when you multiply them you will see that y dash, so because of this property it failed to satisfy this second one, so it's a non-linear. Look about this one, so highest derivative occurring as y dash, so degrees order is 1, it is free from radical, so highest power is 1, but due to the product of the dependent and its derivative it is a non-linear. So it clearly says that degree is 1, but still it is a non-linear. In this case, what is the highest order is? It's a y dash, again it's a y dash, so it's a 1. How you find the degree? It should be free from the radical, so you have to firstly simplify them. I can take this as a square, then it will be a square 1 plus y dash square. So if you open them, it will give you a y square plus x square y dash square minus 2xy dash is a square plus a square of y dash. So y dash highest degree is my 2. Is it linear or non-linear? Clearly say that it's a non-linear. Why? Because of this involve of the y square. Y square can be written as y into y. It is a non-linear. Similarly, if you look about that, these are both are my non-linears. What is the highest degree is 1. It is a 1, so it is a linear. Look about that. What is the highest derivative is my 2. Degree 3, so it's a 3. It's a non-linear. Degree 3. Power is highest order 3, degree 1, but because of these two terms which are in the product form, it is a non-linear. In this case, degree is my 3, order is my 3, degree is my 1, and there is no term which is in the product form, so it is my linear. Look about this one. It's a order is 1, degree is also 1, but because of this y square, it's a non-linear. So it means that only this is my linear, rest all are my non-linear. So clearly says that whenever you can clearly say that whenever degree is my greater than 1, whenever degree is greater than 1, then it is always be a non-linear. You can see it is a non-linear, non-linear, non-linear. But converse is not true. You can see that degree is 1, but it's still a non-linear. Check whether it's a linear or non-linear. So what is the small t is? T is my independent variable, so that's a linear. But when you open this, you all know when you open this, it will contain the term of sine 2y as well. Sine a plus b, sine a cos sine a, sine a cos b, cos a sine b. So because of this sine, when you open this sine of 2y, and we all know how you open this sine y minus y cube upon 3 factorial and so on. Because of this y cube, it is a non-linear. Since it is a sine y and y is my dependent variable, so it is a non-linear. What is the order is? Order is 1, degree is 2, but because of this y dash square, because of this, it's a non-linear. Moreover, in this case, what is the degree? Degree is my 2, so it's a greater than 1, is a non-linear. Mode of y is a non-linear, so it is a non-linear. Mode of dy by dx, again it's a non-linear. Now you can see this is a tan y. So because y is my dependent variable, so tan y, when you expand them, it will be in the form of the y cube and so on, y square by 2, and so it is again a non-linear. So all are my non-linear functions. Now once you are defining the differential equation, then how you can find the solution of this? For example, this is my first order differential equation. I can write as here. So clearly says that what is the order is? Order is my 1. What is the degree is? Degree is also 1. Is it linear? Yes, it is a linear. Then question arises is how you can find the solution. So solution, anything, any relation between the dependent and the independent variable. In this case, if I write dy by dx is here, so what is the dependent variable? This y is my dependent, this x is my independent. So anything which is the relation between y and x, which can be x square plus 1, which can be of the root x, which can be xy is equal to 4, or any of the things are there. It may be y is equal to sine x. Any relation between independent and the dependent variable, but make sure when whatever the relation is there, when you substitute in this given differential equation, it will satisfied as a equality. When you substitute in the differential equation, it reduces to the identity. What is the identity means? That is the left hand side and the right hand side must satisfy them. Then that relation is called as the solution of the differential equation, or sometimes called as the integral of the differential equation. For example, and make sure that whatever the solution you have, it does not involve any of the derivative is there. Any of the derivative of dependent variable like y dash can never be present in the solution. For example, check whether this is a solution or not. How you can do that? You can find the y dash, you can find the y double dash, and you can substitute here. Check whether it's LHS and RHS are same or not. This is y. You can take the first derivative, take the second derivative, substitute this value which is a 0, so which is the RHS, so hence this is my solution. Similarly, you can easily check that whether this is the solution or not. You can take the first derivative, it will be my 2c e raised to power 2x. can it be, this is my LHS, and I can return this as of the form of 2y, which is satisfied. Now this solution is basically divided into the three categories. One is the general solution, particular solution, and the singular solution. What is the difference between them? Say any of the nth order ordinary differential equation. Remember, it's a ordinary. I can return as any of the relation between x, y, y dash, y double dash, and so on. What is the general solution is? Firstly, you have to check that what is the order. You can see that. What is the order of this differential equation? What is the order of this differential equation is my 2. So there are the two constants are there, C1 and C2. What is the order of this differential equation? Order is my 1. So there is only one constant in this solution. Same for here. When any of the solution which consists of the n independent arbitrary solution, remember this is nth order, so it consists of the n, and the most important thing is it must be independent. So if I consider the y1, y2 and up to the yn are my solutions, and it must be of the independent, then you can say this, then the linear combination of them is called as a journal solution, where ci's are my n independent constant. How you can prove that whether they are linearly independent or not? We all know if I multiply with alpha 1, alpha 2 and so on, and if you prove that each of the alpha I are my 0, that means this set, that is a y1, y2 and so on, are my linearly independent. What is a particular, for example, if I consider here, clearly says that if I take e raised to power 2x, can this be the solution of this? We can check it. What is the y dash is here? What is the y double dash is? 4 e raised to power 2x. So if I substitute here, we can check whether it is satisfied or not. Plus 2 e raised to power 2x is 0. Yes, 0 is equal to 0 is a satisfied. Again, e raised to power x is also the solution of this. You can check that. Now there are the two solutions. Clearly also sees that these both are ex and e raised to power 2x are my li, because they are the function. You can also check about this property y1, y2, y1 dash and y2 dash. If it is a non-zero, then they are li. For example, ex, e raised to power 2x, take that derivative, e raised to power x, 2 e raised to power 2x. What is the determinant of this? So 2 raised to here minus e raised to power 3x. So e raised to power 3x, which can never be 0, because exponential function can never be 0. So it means these are my li. So it satisfied that. Then the linear combination of them are called as the journal solution. What is the particular solution? If I consider this particular value of the C1 and C2, whatever the solution obtained, if I take the particular values to the arbitrary constants, that's called as particular solution. For example, if I consider C1 and C2 as a 1, then we will get this as a solution. If I consider C1 as a 1, C2 as my minus of 2, then this is a solution which is called as the particular solution. What is the singular solution? Any of the solution which cannot be obtained from the journal solutions. What is the meaning of that? Say, consider this differential equation. What is the order of this is 1. What is the degree is? Degree is 2. Is it linear or non-linear? So that's a non-linear. So can you find the solution of this? You can easily find the solution. So assume I simply taken as y is equal to x plus c, because order is my 1. So there is only one arbitrary constant c. Clearly says that this is the solution. It consists of the one arbitrary constant, so that is called as the journal solution. Any of the other solution clearly says that y is equal to 0, also the solution of this, because if you take the derivative, it's a 0. But you can easily verify that y is equal to 0 is a solution. But for what value of c can you find? For what value of the c, that is arbitrary constant, you can impose on this so that y is equal to 0. You can't take c is equal to minus of x, because that is not a constant. So it means y is equal to 0 cannot be obtained from the journal solution. So but it is still a solution, so that's why this is called as the singular solution. That's why the definition of this is a solution which cannot be obtained from the journal solution. So this is the way you can find the singular solution. But how you can find the journal solution, that we will discuss in the later class. Okay, now what is the first order first degree? That's a very special kind of the differential equation which can be written like here. You can see that this order is my 1, the degree is my 1. Fine. But whether it's a linear or non-linear, that depending upon the function of this. Or this, it can be written like this way. If I multiply both sides, you can written like this way. Or I can written like dy upon dx is nothing but my minus m over n. So which I consider this function as my f of x comma y. So this is a very special kind of the differential equation, that is the first order first degree. How you can find the solution of this? There are the several methods. First one is a separable method, homogeneous, linear, exact, integrating factor, many more. We will discuss one by one in our next class. We will see the first lecture on the variable separation methods in our next lecture. I hope till now you can simply learn about the concepts of this differential equation. You can simply like, share and comment on these videos. Share it with your friends. Best of luck, students. Happy learning.